So how you define interference? Hmm. So waves must be coherent. So what do you mean by coherent?
So I think coherent means the waves having same frequency, same wavelength, and zero or constant phase difference.
Yes. So two waves are called coherent if they have same frequency and traveling in the same medium. Okay. But yes, in exam if you write this much, then it may be possible कि your examiner may deduct your marks. So one more condition is that कि they must have constant phase difference. But mind it, this is nothing but the result of these two parts. Okay, if they are traveling in the same medium, they have same frequency. In that case, phase difference will be means has to be constant. It will be constant. Okay. But yeah, anyway, we have to write this much in your exam. Now, interference is of two types. What? And of course, one more thing we say that to have same frequency, same medium, they must be illuminated by same source. Because देखो light में क्या होता है? What happens in the light? That if you take two different sources, then there will be slightest frequency difference, and that will cause phase differences not to be constant. Okay, so that's why for sources to be coherent, they must be illuminated by the same source. Okay.
The same source है तो फिर same ही wave होगा ना,
हाँ हाँ.
same ही wave होगा दोनों को.
So what we are going to do, that we will illuminate with the same source, and we will take a wavefront and we will choose 2 points. So these 2 points will be again the source of two waves. Okay, with same frequency. So that is how we are going to go ahead. So it is of two types. First we say constructive.
सर ये दो अलग waves है या दो same?
मतलब
मतलब इनका सब कुछ तो
constructive interference means ki superposition resulting into maximum intensity. Okay. So A resultant, what was the formula? And we already have discussed ki when this A resultant will be maximum. Okay. एंड पाथ डिफरेंस डेल्टा एक्स इज हाउ मच? याद करो क्या फॉर्मूला था? So in exam they will ask you what is the condition of constructive interference. So this is the condition of for constructive interference. क्या? Path difference must be integral multiple of wavelength. आई बात समझ में? Second is called destructive interference. So when the superposition will result into minimum intensity, okay, then we will call it destructive interference. Okay.
Yes, sir.
So अच्छा, इस केस में आई मैक्स कितना था?
4i.
Good. सब भूल गई एक दिन में. So AR will be minimum in what condition?
Cos phi will minus.
और phi should be odd integral multiple of phi. So path difference should be ठीक है. आप करके देखो इसको. लैम्डा लैम्डा इंटू 5/2 पाई कर दोगे तो आ जाएगा. ठीक है. मीन्स पाथ डिफरेंस मस्ट बी ऑड इंटीग्रल एंड आई मिनिमम कितना होगा?
A1 minus 5.
सब भूल गई. मीन्स ऑड इंटीग्रल मल्टीपल ऑफ λ/2. सो दिस इज योर कंडीशन फॉर डिस्ट्रक्टिव इंटरफेरेंस. ओके. तो इस पर छोटे छोटे क्वेश्चंस आपको दिए जा सकते हैं. जैसे एक छोटा सा क्वेश्चन ले लो. ठीक है. S1 S2 दो सोर्स है. दोनों के बीच में आपको डिस्टेंस दिया हुआ है 4 लैम्डा, वेयर लैम्डा इज द वेवलेंथ ऑफ द लाइट कमिंग आउट ऑफ देम. ओके. अब डिटेक्टर को है कि हम लोग सर्कुलर पाथ पर कर सकते हो या इलिप्टिकल पाथ पर कंप्लीट एक रिवॉल्यूशन दे रहे हैं. देन व्हाट विल बी द टोटल नंबर ऑफ मैक्सिमाज रिसीव्ड या डिटेक्टेड? दिस इज योर क्वेश्चन. So mind it, at this point of when the detector is at this site, so path difference between the waves reaching at this point is how much? Tell me. 4 lambda. 4 lambda is an integral multiple, means here it will be maxima. Now, if it will move like this, so path difference will decrease or increase? Bhagirathi, it will decrease or increase? Huh?
Increase.
Decrease. Here it has to be 0 because it is symmetric. Okay.
Yes, sir.
So there will be a time when the path difference is becoming 3 lambda, because next a smaller quantity than 4 lambda is 3 lambda. Similarly, there will be a point where 2 lambda, there will be a point where lambda, there will be a point where 0. Something like this. Does it make sense what I told?
Yes, sir.
Means ki how many? 1, 2, 3. Count it now. See, there will be one maximum at this point, one maximum at this point, one maximum at this point, one maximum at this point. Which 4? In between how many? 3 lambda, 2 lambda, lambda. So 3, 3 in each quadrant. So 12 4 16. Understood?
Yes, sir.
Now questions is same. You have to find out number of maxima when it is moved on the circular path. Now here path reference is 3.5 lambda.
एक ऑर्डर में 5 नहीं होगा,
क्या?
0 वाला तो मैं ऊपर वाला एक ऑर्डर में 5 है ना मैक्सिमम।
वो देखो जो
फिर बताओ ना, फिर 0 वाला को काउंट करना है।
हाँ भैया पहला वहीं से
तो
चालू हो रहा था। See? See, now these two locations will not have maxima. Why? It's odd integral multiple of wavelength. So these two positions will not have. Here 0, here 0. So they will have. And of course 3 lambda, 2 lambda, lambda. Means ki 3 will lie in between the quadrants. So 3 2 ja 6 and 6 down. So total 12 and 2 at the corners, up and down. Okay. So total is 3 into 4 plus 2, which is 14. सबको समझ में आया?
यस सर। यस सर।
क्या क्या? So now we will go ahead with YDSE, Young's double slit experiment. In short, we write YDSE. So this is an experimental setup to study interference. Okay. So we are taking a single source and illuminating these two sources S1 and S2. Okay, with that. Now,
okay sir,
wave will come from these two sources and they will superpose over the screen. At some point on the screen. Because Huygens principle says that ki waves coming out will propagate in all directions. Okay, so we are considering here that these waves, they are propagating like this and they are superposing at some point at a height y from the center on the screen. And this is a central line which is making angle theta. Okay, mind it, this distance of separation between these two slits S1 and S2, it is very small. It is of the order of mm, 1 mm, like that, 0.5 mm, like that we take. Okay. And separation between the slits and the screen, this distance is very large. It is like 1 meter, as large as 1 meter. So now you can imagine that when we say that angle theta made by the central line will be same as angle made by s1 to this and s2 to this. So does it make sense what I'm saying? Just for explanation purpose we have shown the picture very large. Okay. And separation d very large, but which has to be so small, like 0.5, 0.2, 0.1 mm, like that it remains. Okay. And a screen, they are separated by a distance something like 1 meter, 1.2 meter, 1.5 meter, 2 meter, like that. Okay. So that is why angle. Now path difference between these two waves will be calculated how? We will draw a perpendicular from here. Okay. So if you draw this perpendicular, now this S2n is nothing but the path difference. We are considering this length and this length, both are same, almost. Okay. Because this d is extremely small. This is what we have to understand. Okay.
Yes.
Okay. So path difference at point y will be how much? Suppose this is point P. So what will be the path difference between the superposing wave? So S1 is the normal on S2P. Mind it, actually in other books there is a very complicated method to find out the path difference, but this is the easiest method to find out. Okay. Now of course if this angle is theta, so this angle also has to be theta by the geometry. Yes. So S2n is nothing but d sine theta, for theta being very small. Okay. Everyone is able to understand? देख लो ये थीटा,
Yes.
थीटा कैसे हो
Yes,
रहा है,
sir.
समझ लो इस बात को. If this is normal at this, so it should be normal at this also, because as I told you that this distance of small d is around 1 mm, 0.5 mm, like that. It's extremely small. So if it is normal at this, so it should be normal on this also. So now if this angle is theta, so this should be 90 minus theta, so this should be theta. Okay. Understood the geometry?
Yes, sir.
So therefore path difference is equal to d into theta. Now if you see the triangle, suppose this is your center O, this is your O dash. So in triangle O dash P, triangle this O dash and P we are taking. So what we can say? Tan theta is equal to y upon capital D. Yes, sir. O O dash P. Bhagirathi,
Yes, sir.
Shrestha,
Yes, sir.
because tan theta is equal to theta, so theta is equal to y upon d. Now we will substitute this theta, and therefore delta x will become equal to yd upon. Now we have calculated path difference in the term of y, because as you will vary the position of point P, accordingly this path difference will vary. So we have got the term only related with d theta, dy and d. Now for constructive interference, what will be the condition? Tell me. For constructive interference, delta x path difference must be equal to n lambda, just we have learned.
Yes, sir.
And therefore yn equal to n lambda d. So these are the position of maxima. So at yn is equal to 0, for n is equal to 0, we will get what? This is called central maximum. Means ki at the center what will lie? At the center of the screen there will be maxima. Okay. For n is equal to 1, y1 will be how much?
Lambda t upon d.
So this is your called position of first maximum. For n is equal to 2, we will call.
2 lambda t upon d.
So this is your position of second maximum. Therefore nth maxima,
N lambda d by d.
okay. Now position in like the cases of destructive interference.
सर मैं एक क्वेश्चन पूछने जाती हूँ
हाँ बोलो.
सर हम ये क्यों कर रहे हैं
हे भगवान. चलो डिस्ट्रक्टिव इंटरफेरेंस के लिए क्या था? डेल्टा एक्स वाज इक्वल टू 2n plus 1.
2n plus 1 lambda by 2
तो डी वाई बाई कैपिटल डी. देखना ये डिफ्रेंसिएशन वाला डी वाई नहीं है, ठीक ना. कभी कभी बच्चे कंफ्यूज हो जाते हैं, इसलिए तो मैं वाई डी लिखता हूँ जनरली. वाई डी अपॉन कैपिटल डी इक्वल टू, क्योंकि ऑलरेडी फिजिक्स इतना दिमाग खाऊ है ना. So yn is equal to 2n plus 1 lambda d by. Okay. Now again for n is equal to 0. आप क्या करो ना, इसको माइनस कर दो, क्योंकि ध्यान दो प्लस दो या माइनस दो, इन बोथ द केस वी आर गोइंग टू गेट ऑड नंबर ओनली. वाई? क्योंकि ये थोड़ा सा आपके लिए समझना आसान है. अब यहाँ n इक्वल टू 1 कहोगे तो फर्स्ट मिनिमा कहेंगे, ठीक है. ऐसे n इक्वल टू 0 से चालू होता. तो n इक्वल टू 1, y1 विल बी हाउ मच? So this is your first minima. ध्यान देना 2n minus 1 and 2n plus 1 both are odd number only, but here why we took 2n minus 1? Because that was desirable according to our sequence. n is equal to 1 के लिए first minima we are getting, but if it was like 2n plus 1, then we will have to substitute n is equal to 0 for first maxima. Understood the, sorry, first minima. Understood the point? तो आप ये नहीं सोचोगे कि सर हमने तो कंडीशन दूसरा पढ़ा था, यहाँ पर आप दूसरा ले लिए। तो इट इज़ नॉट लाइक दैट। भागीरथी, यू आर गेटिंग द पॉइंट ना? ओके, नाउ हियर वी डिफाइन फ्रिंज विड्थ। ऑफ कोर्स अभी के क्वेश्चंस बहुत आसान आते हैं इसमें, ठीक ना? तो वो जनरली आपको फ्रिंज विड्थ पूछते हैं, फाइंड द फ्रिंज विड्थ। So what is called fringe width? It is the separation between consecutive maxima and minima. Okay. So बीटा से डिनोट करते हैं हम लोग, कितना होगा बताओ? Does it make sense? And width of central maxima is how much?
Lambda d upon d.
Separation between first minima above and below the center of screen. That will be the width of central maxima. आप जैसे स्क्रीन ले लो, ये है, ये सेंटर हुआ, फर्स्ट मिनिमा यहाँ है, फर्स्ट मिनिमा यहाँ आएगा, तो लाइक दिस विल बी योर सेंट्रल मैक्सिमा इन बिटवीन दिस. ओके.
Yes, sir. Yes, sir.
So it is the separation between so beta naught से इसको डिनोट करते हैं, दिस विल हाउ मच, लैम्डा डी बाई 2d माइनस माइनस लैम्डा डी बाई 2d, टोटल विल बिकम हाउ मच, which is equal to beta, means कि fringe width is same as that of the width of central maxima. अब कहोगे सर ऐसा हमने क्यों किया? क्योंकि जब आप डिफ्रैक्शन पढ़ोगे तो वहाँ पर ये चीज़ें चेंज हो जाएंगी, ठीक है? और इसी चलते हम लोग यहाँ पर इसको स्पेशली करके पढ़ते हैं. So like that all maximas will look, है ना?
इसमें सेंट्रल मैक्सिमा भी तो मैक्सिमा है ना, तो उसका सेम ही काम है.
है समझो बात को, मैं क्या बोला उससे पहले, मैं कुछ बोला कि क्यों इसको हम लोग पढ़ रहे हैं, क्योंकि डिफ्रैक्शन में आपको प्रॉब्लम आने वाला है. डिफ्रैक्शन में ये प्रॉपर्टी होल्ड नहीं होता है, वहाँ पर सेंट्रल मैक्सिमा की विड्थ डबल हो जाती है, ठीक है? मैं बोलूँ तो उसको सुनो. तो दिस योर फर्स्ट मैक्सिमा, सेकंड मैक्सिमा, लाइक दैट. ओके. सारे मैक्सिमास की इंटेंसिटी सेम होगी. ओके. That what is the position of angular position of maxima minima. Okay, so many times they ask this question.
The subtle density same to R.
क्या क्या?
Subtle density same to R.
क्योंकि वहाँ पर सुपरपोजिशन जो हो रहा है, that is equivalent, the superposing wave have the same intensity, that is not changing. Okay, superposing waves में अगर intensity, if there is difference in intensity, then that will happen. Okay, and moreover it's an experimental observation. Yeah, so try to understand this point that यहाँ पर पाथ रेफरेंस का फॉर्मूला हमने क्या देखा था, दिस इज d into theta. Now theta, can we say that theta is the angular position of the maxima or minima? Angular position of p is nothing but theta. Theta is nothing but the angular position of p. Does it make sense? So for that case we will use this path difference formula, what, d theta. Understood the point?
Yes, sir.
So delta x is equal to d into theta, and that is equal to n lambda. So theta n is equal to n lambda by d. This is your angular position of maxima. And when delta x is equal to d into theta is equal to 2n minus 1 lambda by 2, so this will give you angular position of minima. Does it make sense?
Yes, sir. Yes, sir.
Means कि all data just has to be divided by capital D, that's all, nothing else. आप अगर कैपिटल डी से डिवाइड कर दो, यू विल गेट द एंगुलर पोजीशन एनी डेटा. कमिंग टू बीटा नॉट और बीटा कितना आएगा बताओ, लैम्डा बाई डी, दैट्स ऑल. एंगुलर फ्रिंज विड्थ. ओके, बट एक चीज इसमें थोड़ा सा प्रॉब्लम है, लिटिल बिट प्रॉब्लम इज देयर. व्हाट? See, these all things are only for a small angles. We have solved all these equations considering that theta, angle theta is very small. If this theta is like 60 degree, 53 degree, okay, in that case tan theta has to be taken. Does it make sense what I told? For larger angle theta, path difference will be not s to n is equal to d theta, it will become d sine theta. Understood the point? So this is your note point.
अंकल हमको क्वेश्चन में दें.
नहीं, वो क्वेश्चन में डेटा से दिखेगा तुम्हें, ठीक है? थ्रू डेटा यू विल बी एबल टू अंडरस्टैंड. तो वहाँ पर सारा डेटा आपको you will have to consider taking this, like tan theta is calculated, through that you will have to calculate sin theta, and that you can use. Understood the point?
Yes.
So calculate theta from this and use it for path difference. Like, just take this question. So find the position of first maximum. कैसे बनाओगे? The waves which will be reaching at the center, they will have path difference how much? Tell me, fatafat. 5 lambda. So there will be a point P which will be act as a first maxima, and it will have a path difference of how much?
4 lambda.
Everyone is clear ना या नहीं?
Yes, sir.
सृष्टि,
Yes, sir.
भागीरथी,
Yes.
but mind it, wavelength is of order of nanometer, so this a small d is negligible. Okay, a small d is negligible. So now if we are taking angle from the center to that point P, then it will be same as these two angles, or it will be different? It has to be almost same.
Yes.
Yes, है ना बच्चों?
Yes.
So now mind it, suppose this angle is theta. Now if you draw the perpendicular, so what is the path difference? How much you told? 4 lambda na?
Yes, sir.
Now this is 4 lambda and hypotenuse is 5 lambda. So what is the angle theta? I told you this angle theta and this angle
50.
theta will be same. So cos theta is 4 by 5.
53.
37 degree, not 53 degree. Okay. So now tell me what is the
Sorry.
position of first maxima. So y by d is what? Not theta, it is tan 37 degree, which is nothing but 3 by 4. Y is equal to 3 by 4 into d, which is 3 by 4 meter. Means, so this is the position of first maxima. Everyone understood this or not?
Yes.
Find the position of second minima. Sorry, maxima in the previous question. ये आपको खुद से करना है, ठीक है? चलो एक नॉर्मल क्वेश्चन लो. सपोज लैम्डा इज गिवन 600 नैनोमीटर, डी इज गिवन 1.5 मीटर लेट से, and a small d is 0.5 mm.
ऊपर वाले कौन से 4 by
हाँ.
ऊपर वाले कौन से 4 by
Find the position of fourth maxima. अब ध्यान दो, in such questions when they have not said anything about what is the arrangement here, okay, in such questions we take common normal arrangement of the YDSE, this one, okay, this one, if nothing is said. समझ में आई बात? दोनों निकालो चलो. Find the position of fourth maxima and minima. Also find fringe width. What is your answer? Y4 is equal to, yes,
Okay.
नैन ये है मिलीमीटर, ध्यान देना, तो इंटू -3, तो दिस विल बिकम इक्वल टू, जो भी आएगा ये मीटर में आएगा, ठीक है, आप इसको mm में कन्वर्ट कर लोगे, आंसर विल बी इन mm ओनली, एंड दिस इज योर मैक्सिमा, फोर्थ मैक्सिमा, एंड फोर्थ मिनिमा कितना हो जाएगा, y'4, 4 दूनी 8 -1 कितना हो जाएगा, 7, है ना? हालांकि पता है सबसे अच्छा क्या था, आप लैम्डा डी बाई डी निकाल लेते इन द बिगनिंग, फर्स्ट ऑफ ऑल कैलकुलेट दिस लैम्डा डी बाई डी विच इज फ्रिंज विड्थ, then multiply by 4 and then multiply by 3.5, that's all. Yes.
Mm. Yes, sir.
So that will be far better to do. If in exam this question comes, you should do in that, okay, because saving time is extremely important. Okay, tomorrow we will meet again at 12, and it will be mostly competitive portion of this chapter.